This is section 3.3, synthetic division. So let's just talk about briefly what synthetic division is. It's simply a shortcut method that we use when we're dividing polynomials. And so if you've ever done long division with integers, it can get quite lengthy. Well, when we're dividing by polynomials, it can get just as lengthy and a bit more complicated because now we have variables in the mix. So synthetic division is just one of the options that we can use during certain scenarios. So we'll talk about what the criteria is here in a second. This first slide right here is simply showing a real-world example of where we might be dividing polynomials. Same thing here with the second slide. We see 80x minus 8,000 over x minus 110. So that would be division of a polynomial. Okay, so let's look at our first example. Before we actually start working this, let's talk about how to identify scenarios where I can't even use synthetic division. So in order for me to use synthetic division, I have to be dividing by a linear factor. Okay, so our x in the denominator has to be raised up to the first power, which we don't see that one right there, right, that it's raised to, but it's understood. So when we don't see a value there, we understand it to be 1. If that was x squared, x cubed, anything else, right, then it would not be a linear equation or a linear factor. And so then we couldn't use synthetic division. But in this case, it is, and so we can proceed using synthetic division. Okay, so you're going to take your denominator and set it equal to 0, and then solve for x. Okay, we get x equals -3, so we're going to place that number here in this little pocket. And then I'm going to take the coefficients in the numerator and write those out. Now I have to look at the powers that are in my numerator and make sure that they're in descending order, and they are, right? So I'm going to write this one in here just so we have 2, 1, and then no variable, right? Which would be equivalent to like x to the 0 power. But no, if that is going to throw you, just think, okay, I went from x squared to x to the first to then no x at all, right? So that works. It's in descending order. So now we're going to take the coefficients 4, 3, and -13, and I'm going to write them out. 4, 3, and -13. So that is our setup. And now here's the pattern. You take that first number, that first coefficient from the numerator, and you drop it down. And now you're going to take that -3 and multiply it and put the product right there. So -3 times 4 is -12. And now we add 3 and -12, we get -9, and then you start the process all over. Let me get a different number or a different color. -3 times -9, positive 27, and then we add. So the reason we had to drop that first number 4 was there was nothing to add there, right? But once we drop it, then we say, okay, -3 multiplied by that 4, we got -12. Then you just add. Now you'll add down that column. You get the sum. We multiplied -3 by -4, and now we got positive 27. You're going to continue to add it. So positive 14, and that will be your remainder. So let's look at the numerator. The power that we had, right, and the leading coefficient was x squared. We will always start with 1 power beneath that. So this will be 4x. this will just be minus 9. And then my remainder, it's a positive 14, but it has to go over my original denominator. So x plus 3. And that is my answer. That might seem super outrageous to you, but I promise you the more you practice this, the more it makes sense. So I would maybe write this problem over again and try to do it, and then watch the video and be like, okay, wait, did I, if you get stuck at a certain point, try to see what you would do if you absolutely had to take a next step, and then check it with the video. Okay, that's that same problem that we just worked. Notice the format that it's written in. So right now, it's written out, but we saw it in the previous slide written as a fraction. So just keep that in mind. Okay, so I look at my denominator and I'm like, okay, that's a linear factor, so I can use synthetic division. So I'm going to take my denominator and set it equal to 0. I get x equals positive 2, so that's the number that will go into my little pocket. And then I'm going to go ahead and take those coefficients in the numerator and write them down to the right. Before I do that though, remember, I need to make sure that it's in descending order, and I also need to make sure that none of my powers are missing. So let's take a look at this. I have 5. I don't have anything to the 4th power. I have 3, 2, 1, and then my constant, right? So it is in descending order, but I'm missing that x to the 4th power. So we have to account for that. The way that you account for that without changing the expression is by adding a 0x to the 4th, right? Because 0 times anything will still be 0. So I can add a 0x to the 6th, 0x to the 7th, right? But I don't need to do that because those aren't falling in between the powers that are included. So we're going to rewrite this numerator as 4x to the 5th plus 0x to the 4th. So that's the one I just added in, minus 3x cubed plus 3x squared. So notice nothing else changes, only that plus 0x to the 4th. That was the only thing I changed. Okay, now they're all in descending order. They're still in descending order, but then also I'm not missing any, right? So now I'll go ahead and take my coefficients. So 4, 0, -3, 3, -5, and 2. So 4, 0, -3, 3, -5, and 2. And now I'm set up and I'm ready to start the pattern. Okay, remember that I have to drop this first coefficient and then I can go ahead and start multiplying. So 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. -3 plus 16 is positive 13. 2 times 13 is 26. 3 plus 26 is 29. 2 times 29 is 58. -5 plus 58 is positive 53. 2 times 53 is 106. 2 plus 106 is 108. Okay, so now my answer, remember, let me get a different color here. My leading coefficient in my answer will always be 1 less than the leading coefficient here up in the numerator. So I had 4x to the 5th, so this will be 4x to the 4th. And then we'll just have the rest in descending order. 8x cubed plus 13x squared plus 29x plus 53. That's my constant. Here's my remainder, so plus 108. And then remember to put it over my original denominator of x minus 2. If you do not, then it's going to just look like plus 53 plus 108, right? Which would, then we would combine those like terms. So make sure you include that denominator. And there's your answer. It is the same approach every single time. So practice, practice, practice. I would say to make sure you go down the criteria of saying, okay, am I dividing by a linear factor? Okay, set my denominator equal to 0 and see what number is going to go in my pocket. When I look at my numerator, are they missing any powers? Are they in descending order? And so go through those questions